Being here and looking around, I can't help but think that were it not for Sir Isaac Newton, we might not be here now.
What are you talking about?
Well, Newton's three motion laws in a very real way got us started on a path that ultimately led to the stars.
Of course you are quite right. But still, would you be so kind as to remind me of his three laws?
But of course, I would be delighted. As I am sure you know, his first law is also known as the law of inertia.
Yes, of course. Who does not know that?
Apparently there are a few students at Tolland High School who are still in the dark in that regard.
You don't say?
There are, but getting back to the first law, it basically claims that if no net external force is exerted on a body, then the object will not change its state of motion. More formally, it is stated as an object at rest remains at rest, and an object in motion remains in motion in a straight line with constant speed, unless acted upon by a net external force.
So it kind of tells us what happens to the motion of an object if we don't do anything. If I remember correctly, Aristotle had the first part right about objects at rest, but he had the second part all wrong, and it took the genius of Galileo to get that part of it. But what is a net force again?
You are so right about Aristotle and Galileo. Galileo's inclined plane experiments proving the second part are kind of classic. The net force is simply the vector sum of all the forces acting on the object in question. Now the second law can be stated: if a net force acts on an object, then the object will accelerate in the direction of the net force in an amount proportional to it, but inversely proportional to the object's mass.
Oh yeah, the old F equals ma equation.
Absolutely, but remember that it is a vector equation.
So, pretty much the second law tells us what happens to the motion of an object, if in fact we do something to the object.
I could not have said it better.
So what's the third law?
Basically that one body cannot exert a force on a second body without the second body exerting a force back on the first.
Oh yeah, the old action-reaction principle. More formally, I think it states that for every action force there is an equal, but opposite reaction force.
Exactly. And those forces are exerted on opposing objects.
While I can't wait to share the good news about motion laws with my friends. Bye for now.
Ciao, my little friend.